Hello, so this is my attempt to quickly explain the second half of the chemical bonding notes. So last time we left off with polar nonpolar bonds and polar nonpolar molecules. So now we're up to atomic radius and how gaining or losing electrons affects that. This outcome is probably the outcome every student passes because all you need to remember is that when you gain an electron, you're larger. When you lose an electron, you're smaller. So that's pretty intuitive. Your brain should not have trouble understanding that. So again, lose electron, you're smaller. So sodium is 281 usually. And when it's an ion, it's 28. So it has one less orbital. So it's two orbitals here, three orbitals here, because there's three numbers, right? So if this one has two in the first shell, eight in the second shell, and one in the third shell. So that's why if I was to draw the Bohr model back from the beginning of the year, I would have two in the first shell, eight in the second shell, three in the third shell. And if you remove one electron, then clearly you're going to be smaller. Now, the explanation is actually a little more complicated than that. If you want the more complicated explanation, just message me on Remind, and I will gladly go over that with you. Right. So the next part about this, and again, just to repeat, gaining electron larger, losing electron smaller radius. Right. Ions. So again, elements and compounds are neutral. Right. So maybe jot that down. Elements and compounds are neutral. So that's from lab 13 again. If you forgot or need a refresher, if you have a charge, you are now an ion. So one thing you should know is that compounds with a charge are called polyatomic ions. So that if you see two or more capital letters combined in a fixed ratio with a charge, that's known as a polyatomic ion, and those can be found on table E of the reference table. All right, so you don't have to memorize them for high school because they list them for you all on table E. So what's hydroxide? What's hydronium? Um, what's nitrate, nitrite? All those ions are listed for you. And eventually, if you want to be a doctor or in the science field, you may have to memorize that. So the charge usually indicates how many electrons the element needs to gain or lose in order to obtain a noble gas configuration. I got maybe one of the most questions on our mind about what is this noble gas. So um, if you look at the oxidation state, which is on the top right of the reference table, the element, that's usually how many electrons they want to gain or lose. So again, sodium I said already, sodium is 281. If you lose one electron, if you lose a negative number, you are now positive. Right? If you don't understand that, message me. All right, so 281. If you lose an electron, you're now 28. So sodium ion is 2-8. Why? Because +1 means you lost one electron. Right? Calcium, if you look at a reference table, is 2882. If you lose two electrons, you're now 288. So that should be like argon, right? So argon's number 18, and that's a noble gas. And calcium will end up like argon when it loses two electrons, right? Other examples that include nonmetals, right? So nonmetals gain electrons usually. You know that by looking at the oxidation state. So if you look at the reference table, oxygen is -2. And again, if you look at the configuration of reference table, it's 2-6. When it becomes 2-8, it is now neon, another noble gas, right? Fluorine's the same deal. So if you look on the reference table, fluorine's 2-7. -1 means it gains one electron. And fluorine also wants to have a configuration like neon. And just remember, these are the two most electronegative elements, and you could argue Of the first 20, you could argue they're the most dangerous, right? Depending on who you ask. That's just my perspective, just probably right. Anyways, ionic compound. So here's a new mnemonic. So in the beginning, you had to memorize SNAP. Hopefully you remember what that was. So symmetrical molecules are nonpolar, asymmetrical molecules are polar, right, in terms of the chart. So ionic compounds transfer electrons, covalent compounds share electrons. So if that doesn't bring any thoughts to your brain, just memorize TICS, transfer ionic covalent sharing, right? So if you don't have a science-oriented brain, try to use this mnemonic device. So when you see a transfer of electrons, you'll have an ionic bond. And when you share electrons, you'll have a covalent bond. So typically what we say is that metals transfer electrons to nonmetals. So they say they have mobile electrons. It's often asked on the regions. What type of electrons do metals have? Mobile, because metals transfer their electrons to non-metals. So you should know what an ionic compound is, metal and nonmetal, and you should also know that metals transfer their electrons to the nonmetal. Right? And then covalent, you're usually going to see carbon. Carbon is the opposite of a noble gas. So noble gases don't combine with other elements in general. Carbon doesn't discriminate and loves everybody, right? And will bond with everyone, basically. So you want to complete your outer shell. Man, one thing you really need to understand before you go to college, especially people that want to be in the science field, is that you don't need to, you could memorize it, but carbon is 2-4, right? So it's 2-4. So it wants to be like a noble gas. The next closest noble gas is neon, which is 2-8. So in order to become a noble gas, carbon needs 4 more electrons. So when you see carbon in any structural formula, you should see 4 lines around it, right? So it could look like that, like methane, 1 up, 1 left, 1 to the right, 1 down. So that would be non-polar molecule. Because again, the geometry or geometrical shape is symmetrical, if I'm saying that correctly, geometrical. So up, down, left, right, it is symmetrical in terms of the distribution of atoms, and that's why it's a nonpolar molecule. So I could also draw carbon dioxide, which looks like this. You do need to either memorize carbon dioxide looks like that, or just memorize carbon dioxide is a symmetrical and non-polar molecule because the atoms are distributed, am I saying that right? Distributed symmetrically, right? And one thing you need to recall, and something that you should know before you leave high school, is that how do you know if you have 2 elements, how do you know which one goes first? Or why does H go first in water? Or why does carbon dioxide go first? Or why does carbon go first in carbon dioxide? Because the first element is positive. So in this case, hydrogen would be +1 and oxygen's -2. So why do I have 2 hydrogens? Well, remember, compounds are neutral. So H plus 1, that would give you +2. And oxygen's always -2 in high school. So that would equal 0. So that's why water is H2O and not like H4O or H5O. That does not exist. Sodium chloride, I believe this is in your lab. So sodium is +1, chlorine is -1. Those charges balance each other out. Sodium will donate or transfer 1 electron to chlorine. So if this loses 1 and this gains 1, that equals 0. Lithium bromide. So lithium is +1, it's element number 3, atomic number 3. Bromine is atomic number 35, it should be. So bromine's also -1 if you look it up. So again, the positive one goes first, right? That's for some reason people struggle with that. I don't know why. It's really weird. All right, so lithium bromide. So again, when you're naming these elements, put the positive one first. Right, the next one. Hopefully I'm not taking too much time. Ooh, like dissolves like. So this was on your last side puzzle. So why does the styrofoam dissolve? I shouldn't say melt. So it dissolves in acetone. Melting is different, right? So it's not turning from a solid to liquid purely. It's mixing with the acetone and breaking down. So why does acetone dissolve in styrofoam? I'm sorry, why does acetone dissolve styrofoam? Because they're both non-polar. Okay, it's really important for you to know that. Right? So non-polar molecules will dissolve in other, are mixed with other non-polar molecules. Right? How do I go back? So oil is gas is non-polar in general, right? So octane, butane, propane, those types of gases for fuel, even natural gas, methane, those are all non-polar, and they will dissolve. I fed you like 5 minutes. I fed the cats like 5 minutes ago. So water dissolves in other polar molecules, or water will mix and dissolve other polar molecules, like vitamin C and vitamin B. Right? So if you look at the geometric shape of those two molecules or those two vitamins, they will be polar. Fat soluble vitamins like vitamin A, D, E, and K won't dissolve in water. So if you have too much vitamin C, and you drink enough water, you'll flush out the vitamin C. Can't do that with vitamin A or vitamin D or vitamin E or vitamin K. So be careful. The vitamin industry doesn't really advertise that because they want you to take more vitamins. But if you're having a healthy diet and you're actually monitoring all your vitamins, you really don't need a vitamin supplement. I just saw a documentary about people that survived into their late 90s, and they study their diet, how much, how many vitamins they took, how much alcohol they drank. And it turns out that taking a vitamin supplement did not increase their life span, or did not contribute to their, to their health in terms of how long they live. So, vitamins are good, but I would get them naturally through fruits and vegetables, not through a supplement, unless a doctor tells you to do that, right? So this is the last slide. And this is a slide a lot of students struggle with: intermolecular forces, right? So the forces between molecules, right? So water has a strong intermolecular force, which means they have, well, to pull them apart would take a lot of energy. So that's why water has a generally a high boiling point compared to other liquids, right? So this is actually a typo here. Octane actually has a high boiling point, not because it's non-polar, only it's because it's a large molecule. So methane actually has a very low boiling point, and methane is non-polar. And this is natural gas. So, I mean, yes, methane is natural, but just because something is natural does not mean it's good for you. Your poop is natural. You're not going to eat your poop, right? Just be an educated person. Don't say it's natural as a reason for eating something. You should, look at the nutrients behind it, and then to make that determination whether it's healthy or not, right? So again, what you need to know is that polar molecules or ionic molecules have a high boiling point, melting point. They're strong intermolecular forces. You should keep in your brain that polar molecules. You should keep in your brain that water is always a polar molecule. And non-polar molecules, in general, have lower boiling points and melting points compared to polar molecules. Right? And again, that was a typo. Octane has a higher boiling point than water because it's a much larger molecule. Octane is C8H18. And if I could do my math correctly, 96 plus 18, that should be about 114 atomic mass, right? 8 times 12 is 96, yeah. So 96 plus 18, yeah. So it weighs 114. Water only weighs about 18, right? So since this molecule is much larger, it has a higher boiling point. But methane, CH4, has a mass about 16, and water we said was 18. So when you have similar mass, the one that's polar is going to have a significantly higher boiling point, right? And determining molecules of highest polarity. This part actually is not in the regions anymore, but it's good to know in terms of what makes something polar. So if I were looking at HF versus HCl, right? These are two polar molecules because they're asymmetrical, right? I have H on this side and then F on the other side of the bond. So it's a polar bond because it's two different elements, and it's a polar molecule because the whole thing is asymmetrical. And we have HCl here. All right, so again, same thing, polar bond, polar molecule. But if you look at the electronegativities on a reference table, hydrogen on a reference table should be 2.2. If it's not 2.2, it's like 2.1 or something. Fluorine is, actually it's 2.2, I'm pretty sure. Fluorine is 4.0. Hydrogen is 2.2 again. And chlorine is 3.2, I think. Whatever. I mean, it's lower than 4.0. So if you were to ask which one is more polar, they're both polar, right? You have to look at the difference between the charge. So it's a little bit of math, so use a calculator. So the difference between 4 and 2.2 is 1.8, which the math is done for you here. And the difference between 3.2 and 2.2 is 1.0. Right, the math is there. So HF is a more polar molecule because the difference between hydrogen and fluorine is larger than hydrogen and chlorine, right? So that wraps it up. Hopefully that wasn't too long. Message me and remind if you have any questions. And that's it. Thanks for watching.